So I made some changes. The voxels are they're tiny now. I made them tiny. And this allows for a very cool organic look. I also was able to make them look a little bit different by adding an effect that changes their color a teensy bit by their position. I also added greedy meshing. So we'll be talking about this today. It's very cool. It's very fast. It loads like 10 times faster than it did previously. Here's a side-by-side comparison on what it looks like with greedy meshing. And this is what it looks like without greedy meshing. As you can see, there's a lot of vertices that we don't need. So greedy meshing really optimizes things a lot. As you can see when we zoom out, the whole mesh becomes black because there's so many vertices. And vertices are bad because, it takes a lot of time to compute them and everything. So that's where we use greedy meshing. So what is greedy meshing? Well, greedy meshing is basically a way to not draw as many vertices. As you can see, there were significantly less vertices when we use greedy meshing. So basically, let's pretend that this is a cross section of our chunk. If we took a knife and cut our chunk in half or something, and then turned it so we look at it in a 2D view, we see something like this. Also, for the sake of this demonstration, let's assume that each of these blocks is facing air blocks, because we only draw quads when we're facing, air blocks, and there's no blocks next to these blocks. So let's just assume that there's no blocks that are next to these blocks. Okay, greedy meshing. Since greedy meshing only meshes together blocks of a certain type, we need to group blocks that can be meshed together. So we start by choosing the block of a certain block type at 0, 0, and we select it. To grow our selection, we first check if we can grow vertically. We can't because there's no sand block above this block, so we don't grow vertically. Then we see if we can go horizontally, and we can grow horizontally. So we grow horizontally, and that's our selection. And we would draw vertices. Let's make this a bit bigger. We draw vertices here, 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 here. So our quad would look something like this. Then we would basically clear these blocks so we don't select them again. So we'd temporarily clear these blocks so we don't select them again. Now normally you'd go vertically, but since there are no blocks above the block we just picked, we can move on to the next column. Since there's no block here for right now, since we cleared it because we selected it, we move up and we select a sand block. Again, we can't move up, so we move horizontally, we stop, and we clear the blocks. There are no blocks above this one, the block we just picked. So we move on to the next column. We select a grass block this time. Again, we can't move vertically, so we move horizontally. And then our mesh will look something. We're all said and done. Like this. Which is much simpler than making vertices at every single block. So basically just go through every single cross section, from right to left to right, down to up to down, basically checking if blocks are facing air and doing a greedy meshing algorithm on them. That's basically how I do greedy meshing. I also optimized by converting all ints to bytes. Everything that was using, every array that stored integers, like I was storing blocks as numbers from like 0 to like 4, I now stored them as bytes, because bytes take less storage in memory. And even though bytes only can store numbers from 0 to 255, I don't need numbers that are greater than 255. I don't have that many blocks. So replacing them with bytes is much better. I also replaced all lists with dictionaries, which allow for quicker lookup times. Instead of looping through the list to find chunks, I made a dictionary with the chunk position as the key, so I could easily find adjacent chunks without looping through